In this video, we're going to solve a number of inequalities, some regular inequalities, and then also some compound and double ones. Let's get started. Let's consider the inequality 3 times 2x minus 1 is greater than 5x plus 2. Now we want to start with simplifying this left-hand side so that these terms are easier to move around. The goal here is to isolate the x so that we can see exactly what the range is that x can be in this inequality. So let's go ahead and simplify the left-hand side. 3 times 2x. We'll pull down that minus sign. Now let's simplify this even further. 3 times 2x, that's going to be 6x. Minus 3. All right, so that's simplified. We'll pull down our inequality operator, and then 5x plus 2, that's already simplified, so we'll pull that down as well. Now we want to try to isolate our x, and I see that we have 5x's on the right, 6x's on the left, so I'm going to take away from the right-hand side 5x's, and again I want to do the same thing on both sides. So subtracting these values leaves me with, on the left, just 1x, and I'll rewrite minus 3, and this is greater than, well, 5x minus 5x, those cancel out, and all I'm left with on the right-hand side is 2. Our x is almost isolated. Let's remove this 3 here by just adding 3 to both sides. Minus 3 plus 3, those cancel out, and 2 plus 3 is 5. So what we're left with is x is greater than 5.
Now let's plot that solution on a number line. For the solution x is greater than 5, we're going to draw an open circle at the point 5.
And we'll have our arrow here that just goes on forever. Let's look at another problem. 4x minus 3 is greater than 11, and 2x plus 1 is less than 9. Let's try to solve each one at a time. Let's start with the left-hand side here. So again, we want to try to isolate this x. First, let's move this 3 over. We will add 3 to both sides. It's going to cancel out this 3. And 11 plus 3 is 14, so we can rewrite the left inequality as 4x is greater than 14. And now all we need to do is get rid of this multiple on the x here. And to do that, we can simply divide by 4. The same thing to the other side. These 4's cancel out, and what we're left with is x is greater than, well, 14 divided by 4, that's not a whole number. 4 goes into 14 evenly 3 times with 2 left over. That 2 is half of 4, so that's 3.5. And another way to write 3.5 is 7 over 2. We've isolated the x on the left-hand side. Now let's do the same for the right. So we have 2x plus 1 is less than 9. So we're going to subtract 1 from both sides of this inequality. It's going to cancel out this one, and 9 minus 1 is 8. Pull down our inequality operator, and then we'll also pull down this 2x. So we have 2x is less than 8, and we want to divide both sides by 2 to get rid of this 2 multiple. And luckily, 2 goes into 8 evenly. We know that that is going to be 4 greater than, these 2's cancel out, and then we're just left with our x. This whole compound inequality up here simplifies to this one down here. Now we've solved for x for both sides. Can these be true simultaneously? Because if not, this entire inequality has no solution. And a good way to see if compound and equalities have a solution is to draw out a number line. Let's see, 7 over 2, that evaluates to 3.5. So x is greater than 3.5. So what we're going to do is we're going to draw a circle here starting at 3.5, but not fill it in. So that's the left side of our compound inequality. Now let's look at the right side. X is less than 4. We're going to draw a circle at 4 and then an arrow going all the way this way. The solution here, we do have a solution, and it's going to be this range right here. That range, if we remember from the previous video, we can write in simple notation. So we have on the low end 3.5. And on the high end, 4, but we're not including either of these. So these are the limits. So we go up to those limits, but we don't include them. And so in that case, we write the parentheses. Again, if we were going to include it, we would use the bracket. this range is the solution to our compound inequality.
All right, let's do one more.
Let's consider the double inequality. 2 is less than or equal to 3x plus 1, which is also less than or equal to 8. Our goal again is to isolate x. So we want x in the middle here all by itself. So how can we do that? Well, let's first subtract the 1 from the middle. Let's do minus 1. But in this double inequality here, we have to do the same thing to all three parts. So we're going to subtract 1 from the right side also, and also from the left side. So what does that leave us with? The very left side, well, that is going to be just 1, 2 minus 1. We still got our less than or equal to sign. Pull down our 3x here. Now these two ones have canceled out, so in the middle there's no more 1. And on the right hand side, we've got 8 minus 1, which is 7. Now all we have to do is get rid of this 3 in the middle, and we can do that by dividing 3x by 3. That's gonna take that 3 right out, but again we have to do the same thing to these other two sides. So 7 divided by 3 on the far right side and 1 divided by 3 on the far left side. And we should be done. So we can rewrite this as our x is in the middle. Our x is greater than or equal to 1/3, and it's also less than 7/3. We could write the number line out to get a picture of it. So since we're dealing with thirds everywhere, we can make these increments thirds. We can start with 0. Our x is greater than or equal to 1/3. So since it includes that 1/3, we're going to circle in that bubble, and we're going to go all the way up to 7/3, but we're not going to include it. So we're not going to fill that bubble in. And then we have this line in the middle.
So this is the solution, all the values that x can be for the double inequality. 2 is less than or equal to 3x plus 1, which is less than 8. And we could also rewrite this range in interval notation like this, with our bracket on the left and our parentheses on the right.